Welcome to Forecasting Impact, a podcast brought to you by the International Institute of Forecasters. This show brings together experts from academia and industry to discuss a wide range of subjects on forecasting science and practice in business, society, economy, healthcare, and education. Thank you for choosing to spend some time with us today.
Hello, everyone. Welcome back to Forecasting Impact. My name is Mahdi Abolkasemi. I'm a senior lecturer in statistical data science at Queensland University of Technology in Australia. And today I'm joined by brilliant co-host Mariana Menchero, joining us from Mexico. How's it going, Mariana?
Thank you. I'm very happy to be here talking to you and to Rami.
Thank you. I'm really thrilled also to introduce our guest, Rami Krispin. If you have been following the work on MLOps and time series forecasting package developments in R, you probably know Rami, but I'll just give a quick introduction. Rami is a senior data science and engineering manager at Apple, specializing in forecasting at a scale and machine learning operations. He's the author of Hands-on Time Series Analysis with R and also an active contributor to the forecasting community through his R packages and a very active newsletter. So let's start with this, Rami. You've been working on forecasting and data science for a long time. What first got you started in this space?
By coincidence, purely coincidence. I was doing my master's in economics, and I planned to go to PhD. And then there was change in the plans toward the end of my degree. And a friend called me and told me he has a friend that is looking for a data scientist in McKinsey. And I asked him, what is a data scientist? We're talking, I think, 10 years ago. And I don't know, it was not as obvious as today. And he told me, is it someone that take data and make sense out of the data, is building regression and classification. I was like, okay, applied statistics. So the next thing I did before starting the interview process was going to Barnes & Noble. It's a bookstore here, and bought a book, Introduction to Data Science. And I think that changed my trajectory from, going to be, I was debating if to do, I studied actual science or economics. And I think that's when you start to read a book, it's like a black hole. It sinks you inside, and that caused to a change in my trajectory of what I planned. And from there, I started my first role as a data scientist, and that's how also I got into eventually to forecasting on my first work at Ernst & Young.
Awesome. I must say that we have been interviewing a lot of people during the last 5 years. And many, when we ask this question, how did you start it? And many say by randomness. And that seems like to be a pattern in how people get started in forecasting, or maybe other things as well, but a very interesting one. Yeah.
And Rami, after getting into time series forecasting, you wrote Hands-on Time Series Analysis with R. What motivated you to write this book, and who is it for?
It was also by coincidence, I must say. At that time, they were the first few years of my career. I think that's like every or some data scientists, you're doing a lot of experimentation, and that's how I got into time series, and I started to write a library for time series applications, and that's how the book publication reached out to me and asked me if I want to write a book about it. And at that time, I was surprised that someone actually reached out, and it was always seems to me at that time in my career to write a book is something very novel. So I decided, okay, let's take the challenge, and that's how I started the journey on writing the book. That was the starting point.
And yes, throughout the book, you use TSstudio, an R package that it's now on CRAN. And can you tell us a little bit more about it?
Yeah, The reason I started this book, the package, is from necessity. I remember probably more than one person. It's a code from more than one person. If you're using the same function more than 3 times, write the package. And I found myself moving at that time at my previous work, moving from project to project and copy paste some of the code, and I just decided to package it and make the initial analysis of time series and all the utilities that you need to do time series analysis to wrap it in a functions that will be seamless to go and explore time series data.
Okay. And TSstudio supports Bayesian structural time series, which are not as common as other models, say ARIMA or LightGBM. Can you tell us more about these models and when they should be used?
The BS Bayesian time series, structural time series. So I think I got to this by coincidence, to this BS TS. I forgot what are the initials to this model. The person that wrote this package, or one of the people who were involved, is Al Varian. He's a very famous economist. And at that time, I think he was working for Google. And I don't remember exactly. I was Googling to add some issue with some time series, and that's how I got to this library. And I think today everybody familiar with Prophet, but essentially that's it has a lot of similarity with Prophet. It's using Bayesian modeling on the backend. It's also using some additive functionality. So you're building components, trends, seasonality, and it added together. But the regression is use Bayesian. So I started to use it, and it was at that time really nice. So I decided to add it as a support for this library for visualization of the outputs and so on.
Yeah, just for our audiences, could you tell a little bit more about the TSstudio as well? Like, what are the things that you've included in this package? So,
Yeah, I would say that it's probably example of early, like it was one of my main or the first libraries that I actually wrote that went to all the way to Crane in R. And so it was a journey, and this is the journey that today probably will do it differently. At that time, I was like really eager to learn, and also today. But at that time, I had less experience. So usually, people with over passion tend to have like a scope creeping, and so I included a lot of features that today probably I will split it into multiple libraries. But essentially, its key functionality is the visualization. So I like to use interactive data visualization. I think that especially in time series, it has value that you can go and over the data or zoom in and get quickly information. So I use Plotly on the backend, and essentially it's provide a lot of it's a wrapper for a lot of the key functions in R that are available in base R. For example, the autocorrelation function plot. So it provides interactivity. It adds some colors that is not available in the base R functionality. So for example, I added the seasonal leg with a red color to that will very quickly to see if you have high correlation on your seasonality. And I also added some functionality for training time series and evaluation of a forecasting model. So function to back testing. And that today is very trivial because every library today, or for most libraries, are coming with this functionality. If you're looking at the Fibel or on Nixla in Python and other libraries in Python, you have this functionality. But at that time, I don't think it was as common that you can go and run
Mm-hmm.
backtesting. So I built this functionality. So yeah, there are a lot of helper functions. Probably, today, where if I had to write it again, I probably would split it into different components in different different libraries.
Yeah, excellent. Just out of curiosity, are you working on any new packages or packages?
Unfortunately, not currently. The main reason
Yeah.
that I'm working on, I finished one course on LinkedIn Learning for data automation with GitHub, so it took a lot of time, and now I'm working for a second course for data camp that's going to focus on forecasting.
I see.
And I'm trying also to write a book. So I'm trying to, again, that's I think a level of maturity that you are limit your scope to be able to finish stuff and not overscope and try to do too many things and not get them done.
Yeah,
That's right.
and beyond TSstudio, you have contributed several data packages to the R community. Can you tell us more about them?
Yeah, mainly I love data. I love time series data. It's a I guess if people some people have weird hobbies, but I love to go to APIs, and it's a habit that I started to develop when I wrote the book. When I was looking, for example, for time series data, and I found some great examples, so I decided to package them, and that other people can also use them. So over time, I started to look for example. Whenever I found something nice, I package it. So there is one that is focused on electricity data from the UK. I think it's electricity data. The second one is the contain a lot of time series from describing consumption of natural gas in the United States. And there is also another one related to demand for electricity in the United States. Those great examples for both hourly time series data and monthly. And so you can, if you have, whenever you want to build some examples, it's easy to use those libraries that just to pull them. I think that today I see it more and more in Python, but R has a rich internal data sets that are built in R, and it's very common in R to package data, which is less common, I believe, in other languages.
Excellent. So Rami, I was looking at your profile, and you mentioned that you're writing a new book. What's that book? And I believe you're tackling scaling forecasting practices, if I'm not mistaken. But could you tell us a little bit about that?
Sure. When I wrote my first book, and for those who are familiar with our TS was the main object for time series, and the forecast library by Professor Robinman was the most popular tool. And that was something that was great at that time, where most of your time series was either monthly and you have one, two, or dozens of time series. But as time progress and the amount of data we can collect scale, we reach out that problem that of scalability. And when you are doing some traditional time series analysis, is based on you taking a time series, you are plotting it, you are doing some correlation analysis, you are doing a seasonality analysis, and you based on this you can understand what type of models you want to fit or what features you want to create. And this can work when you have one or few time series. It's becoming hard to do it when you have hundreds or thousands of time series, and this is where you need the scalability problem. So I think that today most of the industry, that's the problem that you will face. You need to handle dozens or hundreds or more than that high scale of time series, and the book is about how to approach this type of problems.
I see. So, in a nutshell, what is the main challenge of the scalability that you would, apart from the computational resources that we need, is there anything that we need to change in the way that we approach our modeling? And
Yeah, I think to get depending on the first thing is depending on your time series. If you're doing a forecasting of a beautiful time series like a demand to natural gas, which is fairly seasonal. It's like the very close to the air passengers, right? It's no matter what model you will throw on it, it will work. So you
Mhm,
don't need to focus on handling outliers to handle complex seasonality or
mhm,
structural break season, uh, different events that you need to build features. In real life, you're not that fortunate unless you are working in energy sector. Your time series are abrupt change. For example, recent pandemic changed a lot of different industry. Like if you look at passengers data, you can see that there was a huge drop during the pandemic, and then there was a recovery, and then some of the patterns stayed, but some change. You not always return to the same point where you were before. So this is where if you need to build features, the feature engineering is the challenge, and this is where
mhm,
it's very hard to if you are really dependent on the features, and this is where it's very hard to scale.
mhm. Yeah.
And Rami, you're also recognized as a Docker captain. Can you first explain us what Docker is and how this has helped you in your time series work?
Sure. Docker essentially is a container. It's a enable you to wrap your code inside the container and reproduce it in across different machines. So um, essentially, what you're doing with containers, you are setting an environment. And if I'm working on that environment, I can shift you this container, and you can work with using the exact same settings that I'm using. So it's cover, in my opinion, it's a in data science, one of the fundamental principles is reproducibility, and this is where Docker is super helpful. It enables to reproduce. It solves issues that there are different level of reproducibility. When I was student, I learned that reproducibility is set the seed, and but then like when you go to the industry, you hit the reality and you understand that set
Yeah, it's
seed
more
well
than
can
that.
save you can save you to certain extent, but then there are some other constraints of the environment, and that some of it virtual environment solve, but then there is the type of OS, the compute, the CPU type, and other factors that this is where Docker is solving and handling very well. And the example that they usually like where you find the need to use Docker is either when you are working in a team and you are collaborating. So it's easy to, when you are open a PR, you're also providing the environment with Docker, and people not, do not need to spend time. I'm getting this error because I'm missing some library, or I'm getting that error because I know something on the settings. So it's a for efficiency, but also when you're deploying from your local machine to a server, it smooth the process. And you probably saw in your career, uh, this Stack Overflow issues that it's worked perfectly on my machine. So this is what it solves. Like you are start to develop your whatever. It's not necessarily limited to, definitely not limited only for time series, but you start your development by setting the container. And once you reach to some level of maturity in your development and you're inside your container, you can shift your code to a different machine on a remote server, and with high likelihood that it will work smoothly without any issue. There are always could be some other stuff that are not related to reproducibility, but it's ensured that you can deploy smoothly. In the context of time series, um, I can tell you before I used it, like the classic example is like a Prophet. Prophet is every data scientist use it at some point in their career, and then you realize it's. I love the idea behind of Prophet. I think it's open. It was a very new and unique at that time when they released it. Breaking through a library, but there are some issues about the code reproducibility, and the reason that it was the R version, and I believe also the Python version, is calling on the backend Stan, which is a library, a language to Bayesian application. And that language is calling on the backend to some C or C++. And this is where things could get wrong because if you're working on Mac, you have one C compiler, and if you're deploying it on some Ubuntu server on some different machine with different settings, it might have different compilers. And this is where if you're not use the exact same components, you get to prompt reproducibility, and this is where C doesn't help you because it doesn't pass between the languages. So I think wherever you are deploying stuff, again, it's not unique to time series. It's very helpful, but in time series, definitely when you are deploying models, it's really Docker has a relatively high learning curve, but once you are getting there, the dividends are there on the time you need to spend on debug or you can deploy smoothly. It's opened a lot
Yeah,
of new opportunities.
yeah, I have experienced that horrible if that horrible situation where it works on your machine but not in anyone else. And given your emphasis on reproducibility, what other common mistakes do you think people make, especially when they first start working on time series?
I think that sometimes I see people that are rushing to go to the most fancy and shiny stuff in time series and skipping the foundation. I think you really need to know good statistic, probability, and linear regression. If you know those components, understanding how XGBoost or some deep learning models is easier, and you also understand how to smooth or handle different situation if you understand the foundation. If you are skipping the foundation, sometimes it's very hard to return back and get them right. So I think that's where I always recommend people. I remember also myself as a young data scientist always trying to try the other boost, before the actual boost, it was the other boost models and all those stuff. But understand first like how linear regression, logistic regression is working, and then go to the fancy stuff that sometimes are working better than the basic models. But if you understand the basic models, you can really customize them better and get a better results.
Yeah, could you elaborate a little bit more on basically a good workflow for training and deploying forecasting models, including MLOps, for example? What would be a good workflow in your view?
I think it's starting with the admin that related to this, so it's like understand what you're trying to solve, and based on this, understand what data you need, and when you understand those, what is the problem statement that you have, and the timeline, then you can start to think how much effort or what are the tools that you want to use. If you a traditional, time series forecasting, I think it starts with some analysis, and again, it's the question here, like the scale, uh, to do some mapping process, understanding, for example, a common problem that you have many time series, but the length of the series is not equal. So you will have a series that you will have maybe 5 years, and then you have something skew of a product that is new, and you have only a few months of data, and then you need to make a decision. How do I train models with a different time period? Like, is it one model for all, or you want maybe to have some strategy that I want to try this type of modeling for this use case, and I want to use other strategy for uh, different type of data. And I think this is where the segmentation is important. Um, I think also setting expectation with your stakeholders is important about what you're going to deliver. It's not like people sometimes tend to think that data scientists are doing magic. And I think it's important also to explain the limitation of your outputs, and uh, essentially forecasting is based on historical. If your history is going to represent the future, so then you should trust it. But also sometimes there are some cases that you need to know your limitation and understand where you should advise your stakeholders that you should be careful, because it seems like that there is some changes that we cannot factor in the model. So that's kind of like before you're starting, I think, setting expectation. But then, like, when you are starting, you should think about data. Data is where things will start and fall. You should think about your data pipeline. Once you have the data pipeline, and you acquire your data and it's clean and ready to process, you need to think about experimentation process, where you're going to how you train your time series models, and there are more than one way to do it. You can use some backtesting, which is my favorite way to run. I love to run some horse racing with a backtesting, so you get different flavors of models, and then you can choose for each series what works best on the testing. Once you finish with experimentation, the experimentation is a process that could take different iteration. The next steps is to evaluate the performance and select the model, and then once you have the chosen model, the next step is to put it in production. So this is, definition of production could vary from project to project, or depending on, again, like the timeline that you have. But essentially, you want to deploy your project in production whenever it's reoccurring, and you want to automate it, which today's many of the use cases are. It's not just I am doing a forecast and it's done. It's you want to repeat this forecast. It's a repeated process on some cadence of like every month or every week or every hour, depending on what industry you are. And so this is where the last step is to set the monitor the outputs, and have a process that you are score your models as you go, and you identify if you have drift or in your performance, and kind of like set the alarm when you need to go back and retrain the models. So that was maybe a long answer, but essentially data, experimentation, deployment, and monitoring.
I think that's a very good answer, and actually, this is an important topic, right? We can talk about each of those, in particular back testing, how you do it, and then evaluation, how actually you can do evaluation. That could be another episode just on that topic. But I just want to ask a little bit more about the production phase, MLOps, because that is something also you have, an active newsletter and an active role in that, producing a lot of stuff. So what are some of the challenges in that production that, for example, reproducibility is a big thing. And scaling it up as you've mentioned. But is there anything else you want to just shed light on?
I think yes, the reproducibility is the first and foremost, and the second thing is how you do there are so many components that are involved depending on the complexity, but it could get very messy really fast. So I think a good design, you need to think about design as much as you can, and then even if when you're starting with a good design, things might change along the way, and you need to be flexible. And there are some stuff that you may account after the fact that you deploy, and some cases that are known that you don't know at before the deployment. There's you need to make sure both the orchestration, I think it's the challenging part, right? So you need to build the orchestration to be able to get data in, then connect it to log it, to validate it, to put a lot of guardrails to make sure that you don't have any data integrity, and then to make sure that your models are performing well, and if not, you need to go and check why. So think about it: when you have dozens or hundreds of thousands, you really need to build like something efficient and easy to monitor. And that's something that it's not that trivial to build it at this high scale.
Yeah. Excellent. I just want to mention one thing, because we keep coming back to reproducibility as an important thing. In International Journal of Forecasting now, if you want to publish a paper in International Journal of Forecasting, which is our main community for this podcast as well, you have to have a reproducible work. So this is an initiative that started, I believe, a year and a half. Professor Pierre Pinson, an editor-in-chief and the board, actually has pushed this forward. And now this is a great thing. If you're putting your stuff there in top journal, then people check for that and to make sure that it is reproducible, every single output that you have and throughout the whole process. And I think, that's just one step to go towards addressing this crisis that we have in reproducibility, especially in academia. Like in industry, if you have something, you can see the consequences. If it is not working, we see it straight away. Okay, this is not working. We need to do something. But maybe in academia, it's not that, it's not that rigorous. But now IJF is taking the lead on this, and hopefully we will see more of this in other journals and as well. So I want to pass on to Mariana. You were going to say something, sorry.
Yeah, following up on these pipelines that need to be reproducible, I would like to talk a little bit more about feature engineering. Last year, you led a workshop on analyzing time series at scale with cluster analysis in R. And what are the challenges of creating features for millions of time series, and obviously in these complex pipelines?
Yeah, I think feature engineering is my favorite topic in time series. I think it's like where you're going to have a great model or not, depend on your features that you're building. I think the challenge, again, sometimes it's a very manual process to go and label. Like annotation is it's something that there are some methods to automate it, but still you need to go and validate that what you thought is that if you're running some algorithm that labels something, you want to make sure to understand what the label is. And the challenge is when you are have many time series is to how to analyze where do I need to put labels, or where do I need to have specific features, or for example, we all know how to fit trend, but sometimes trends as some linear trend can solve to a certain extent. There are some cases that your series have some notes and you want to have some breaking points. So how do you identify those breaking points? And those are things that typically it's hard to scale. And one of the methods that I like, and that was the workshop about, is based on a paper from Professor Rob Hinman about I'm trying to remember the name of the paper. I think it's a time series time series analysis with features, or probably I messed it up, but essentially it's based on using unsupervised methods to identify patterns for many time series. And the idea is very simple, is that you are taking a many time series and you collapse them into each series into a single row. When you build, each column represents some feature. So you can calculate some standard deviation, you can calculate some ACF score, and so on. So you're creating a lot of, you're turning this time series into a tabular format where you associate the time series with its features, and then you're applying some unsupervised method of clustering together with some, you can use PCA, and then it's unsupervised, so there's no right and wrong questions. You're trying to find in the cluster what's unique in the cluster, and based on this you can make a decision. If you have like a cluster of 200 series that looks the same, so you can take few of them, try and find what fits best on like a few of those series, and then try to scale it across the whole cluster and see if it works or not. You can then, so instead of like training, experiment on thousands of series, which will be more expensive, you can start on tune it really well on small subsets and then scale it on the large subset. There are some really nice things that when I test it, that you can really identify like outliers and different things that at a large scale it's very hard to. It's like going to fishing, right, in the ocean, right? So it's very hard to find those things by just like trying to fish something. And it's a really direct, give you directional like where you should look at the time series and which time series you need to spend more time, which similarity, right, on trends or seasonality and so on.
Yeah, it's the TS feature is actually the package that Rob Hyman team has developed. It's a great package and a great way to analyze your time series. I think I've done some work on that, but I know that the second place in AM4 competition also they tapped into this time series features to develop some models and train their models. Yeah, excellent. So just going to move on slowly to the last part of our conversations. We are in a forecasting discussion, and I want to know, what is your forecast for the time series forecasting? What is it like the future?
Oh, wow.
Difficult question now.
If you asked me like a few years ago, I would tell you, scaling, machine learning,
Yeah,
XGBoost, and so on. Today, I think we are introduced in the, I don't know if the last year or last 2 years, the foundation models that are coming into
foundational.
pictures.
Yeah.
There is the Time GPT from Nixla. I know there
Mm-hmm.
were also similar models from Salesforce and Amazon, I believe that I read a paper about it, and maybe other companies, but that's something that I feel like it's still probably experimental, but that seems like that, we might find ourselves faster than we think using it. And that seems to me like, if I need to guess like what will be the future, I would say, along with, and again, like along with scaling, is to be able to use some more sophisticated models to generate a better forecast when you're doing scaling. The issue again, like with scaling, is that there is a trade-off between accuracy and complexity, right? So when you can give more attention to your time series, you obviously potentially can get better results. And when your attention is spread across many series, your ability to tune all series to be the best is limited. And I think maybe this is where the foundation model, so that like the one that were trained on many time series at a large scale, could give you good results.
And following up on that, Rami, do you think R should follow Python's lead, or do both programming languages serve different needs within the time series community? I know this is a hard question, but given your experience as a developer, as an instructor, and practitioner.
I feel like it's a more political question rather than.
We don't want to upset the RStat community.
So,
following.
I'm so when it's come for me, like I'm very R person. So I'm not. I'm. If I'm biased, I would say I'm biased to R. But so that's
me too.
I think that my answer is when it's not coming from a Python person. So I think I can really speak the truth. Not that Python people cannot speak the truth, but you know what I mean. I think that again, like going historically, R was very dominant. If you started on time series like 5-6 years ago, R was the language. There was barely nothing in Python, but in the recent years, Python became the dominant language for time series. And so today, if you map what we have today in R, you have a great models that are from Rob Iman's team, Fibble library, which I really love this library. But it's limited to statistical models. And you have a model time from Matt Denshaw, which is another great contributor to the time series community now, that is more open for machine learning, if you want to follow machine learning approach. But those are the two main ones in R. When you look at Python, there are by far many more options, and the development there is faster. You have Nixla, the stats for forecast, the ML forecast, the neural forecast, and you have Darts, which is another great library. You have a SK time, and there is a SK forecast. So there's many libraries that offer you different functionality, or they have some overlapping between, but you have more options. And I think if I had to choose today, so I would say that Python is the one that I would choose to go with. Again, depending on your use case, and I believe that you should always think about it as more like a practical. What serve you? You should not serve the language, but the language should serve you, right? So what is more serving your needs? And today, I think Python is probably have more options.
Yeah, we were just going on this.
I didn't offend anyone.
No. Hopefully not. No, I think it's a fair conversation, and we were just having this discussion before joining to this recording, talking about Python and R and Julia, and Yeah, we're saying that, if you could also elaborate a little bit on Julia, that would be good. So we have all
Yeah.
these three languages covered.
Yeah, and again, maybe it's a broader kind of like, I think, again, like it's a very opinionated thought that if you think that the three main languages for data science are
Mhm.
Python, R, and Julia, like they have functionality for modeling. Maybe there are others, but like those are the one that I
Mhm.
can think about first. And if you ask me, a few years ago, what will be the future language, I would definitely would tell you Julia, because Julia solve a lot of the what we are struggling in R and Python, that they are slow languages. And in R, if you want to make stuff faster, you are writing stuff in C or C++ or any other machine language. And today there is also Rust, similar in Python, right? So we have the Polars that is written in Rust, and there are other applications now moving to Rust. But then it kind of like you're building one language on top of the other language to make the performance. In Julia, it's natively you're writing Julia, like all the Julia code is written in Julia. All the functionality, and you get high performance. You can maybe discuss about compared to C or C++, but it's fairly fast language. So on paper, this language should be the language of the future. I think that the things that change most the landscape of uh, this kind of like those languages is uh, the rise of the language models, which brought back Python to the
Mhm.
main stage. It was already in the main stage, but it's kind of like now it's real here to stay, at least in the foreseeable years, because we see that still, like you see that most of the contribution to the Python library language are come from either individuals, and there are a lot, and also from companies, which we in our there is the exception of Posit that really kept the language alive, and they're doing great job on contributing to this language. And I think if Posit was not there, the language was dying many years ago. They're always like, you read this article, and I used to get frustration as R users, like 10 languages should die from and they're still here, and R was always there. But and again, I think recently I see R kind of like returning, but I think that the momentum is with Python, and the large language models change the landscape. And if you want to use those, and everybody now want to use those, you need to know Python. You can still do it with R or Julia, but language success depends on the number of contributors, and
Members,
currently it
community.
is. Yeah, and I think that's like you will see that Julia, unfortunately, still I see it as a academic language, and R probably will regress back to the academia.
Mhm. Yeah.
Yeah, I I made that question about R and Python, but I'm an R package developer myself. And as you said, I think you should use the language that works best for your use case.
One of the things that R was great about was, there were some area that until recently, there was nothing available in Python. So if you're using R Markdown, only our user could understand the power of R Markdown. I think that was like,
Yeah.
until you use it, you don't understand how powerful it is. And then came Quarto, which, opened it for Python and other language, which is great. And similar for data visualization, R was very dominant in data visualization. ggplot is it's a amazing ecosystem. But now you can see there is similar things, or not similar, because the ecosystem is what is missing. But there are some Python closing the gaps also in data visualization. So you have Plot9, which is sort of mirror of ggplot2. And there are other great libraries in Python for data visualization, like Altair, Plotly, and so on. So I think today both languages are offering the same with more options in Python.
Yeah. Probably also in the machine learning and deep learning space, Python is way more forward than
Yes, that was always
other languages.
Yeah. I think R started as a machine learning language, but then once Python got into it, it's ran really fast. Yeah,
absolutely. Okay, Rami, I want to move to our last question that I know you have a very active online presence and newsletters. Where can people find you more?
I have I'm generally in many social. I'm mainly in LinkedIn. That's where I'm active. I also in Blue Sky. I have a data science channel on Telegram and WhatsApp. So those are, I think, the main places I am active, and I have a newsletter in LinkedIn. I'm also working on a newsletter about forecasting. It's on my queue. I'm just waiting to finish the course that I'm working to get more time, because those things are taking some time. But I have a lot stuff that I wish I could write more about forecasting.
Oh, great. Looking forward to it. We put down the links and everything in the description so people can get access to that. And with that, I would like to thank you very much. And I would like to thank our audiences for listening to this episode. And until next time, see you.
Thank you so much.
Thank you for taking your time and listening to Forecasting Impact. If you liked this show, please subscribe to our podcast and leave a review. We appreciate you, and we look forward to seeing you at our next episode.